Hello everyone. Today we are going to discuss the concept called all silver teacups. All silver teacups. Okay. So this method is used to find the values of the trigonometric ratios of the angles more than 90 degrees. So we know up to 90 degrees trigonometric ratios values. So in that the fundamental angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, okay, 90 degrees. So actually basically 30 degrees, 45 degrees and 60 degrees, these are called standard angles. And with the help of these angles we know the values of 0 degrees and 90 degrees. So few authors will take all these angles as standard angles, and we know the values of the trigonometric ratios of these angles. Okay, so if the angle is for example 120 degrees, for example I am asking one question, sine 120 degrees. Now to find the values of these, so we use the method called all silver teacups. Okay, now we'll see. So what is this? Okay, so for this I am taking the quadrant structure. Okay, so here we have total 4 quadrants. Now I am calling this as first quadrant, and this is second quadrant, and this is third, and this is fourth. Okay, if you observe the angle in the first quadrant, it will lies from 0 to 90 degrees. Okay, so 90 degrees is not included in the first quadrant. 90 will be included in the second quadrant. Okay, so here this angle is 0 to 90 degrees. 0 will be included in the first quadrant only. Okay, next in the second quadrant the angle lies in between 90 to 180. Okay, 90, more than 90 and less than 180. So 180 is included in the third quadrant. Now the angle in the third quadrant will be 180 less than or equals theta less than 270. Next in the fourth quadrant the angle is 270 degrees less than or equal theta less than 360 degrees. Okay, so if we completed one rotation, the angle is like this, 270 less than or equals theta less than 360. Okay, this is one. So in other words I can say the angles in the first quadrant are more than 0 and less than 90. So I will take the angle as like this, 90 minus theta. Okay, now in the second quadrant more than 90 and less than 180. That means in the second quadrant the angles are 90 plus theta, 180 minus theta. Now coming to third quadrant, more than 180 less than 270. That means 180 plus theta, 270 minus theta. Next in the fourth quadrant the angle is more than 270 and less than 360. So the angle in the fourth quadrant will be 270 plus theta, 360 minus theta. Okay, so if we completed one rotation, the angle in the fourth quadrant is 360 minus theta. Okay, like this, if we completed second rotation, then this will be 2 into 360 minus theta. Like this, if we completed n rotations, the angle in the fourth quadrant will be n into 360 minus theta. And now if we going to first quadrant, so after completing one rotation, now the angle in the first quadrant will be 360 plus theta. Okay, so this is when we completed one rotation, the angle in the first quadrant will be 360 plus theta. Like this, if we completed second rotation, then it will be 2 into 360 plus theta. In this way, if we completed n rotations, the angle in the first quadrant will be n into 360 plus theta. Okay, and we have one more angle. When I am saying theta lies in the first quadrant, then minus theta lies in the fourth quadrant because it is the mirror image. Okay, so when theta lies in the first quadrant, then minus theta lies in the fourth quadrant. Okay, so these are the angles lies in the quadrant structure. Okay, and for first quadrant the word belongs to this is all. Okay, all means in this all trigonometric ratios are positive. Next, for second quadrant, the word belongs to is silver. Okay, silver means in this quadrant, sine and cosecant, these are positive and the remaining ratios are negative. Next, the word belongs to third quadrant is T. Okay, T means it started to tan. So in this quadrant, tan and cot are positive. So the remaining ratios are negative. Next, for fourth quadrant, the word belongs to this is cups. Here the word cups started with C. In C, we have the ratio cos and secant. So for cos and for its reciprocal secant, these are positive and the remaining ratios are negative. Okay. So finally, what I am saying here, in all silver teacups, the first step is, so which ratios are positive in the quadrants. Okay. So in first quadrant, all the ratios are positive. And in second quadrant, sine and cosecant are positive. In third quadrant, tan and cot are positive. In fourth quadrant, cos and secant are positive. This is first step we have to remember. Next, the second step is, the second important point is, in first quadrant, so that means the angles lies in the quadrants. So in first quadrant, the angle is 90 minus theta, 360 plus theta, n into 360 plus theta, and simple theta. Okay, in second quadrant, these two are enough. 90 plus theta, 180 minus theta. If you move one more, so here we get the 450 minus theta and 450 plus theta will be there, but no need to consider that angles. These two are enough. In second quadrant, the angles are 90 plus theta, 180 minus theta. Next, in fourth quadrant, 180 plus theta, 270 minus theta. Next, in fourth quadrant, 270 plus theta, 360 minus theta, n into 360 minus theta, and minus theta. Okay, this is second point. Now coming to the third point, so here whatever the angles are there, in that if you observe, we have totally 90 plus or minus theta angle is there. Next to 270 plus or minus theta angle is there. Okay, these angles are called, so if you observe this, these are called odd multiples of 90. Okay, odd multiples of 90 degrees. Okay, and coming to the angles plus or minus theta, 180 plus or minus theta, 360 plus or minus theta, n into 360 plus or minus theta. These are called even multiples of 90 degrees. Even multiples of 90 degrees. Because here if you observe 90, that means we can write this 90 as 1 into 90. 1 is odd number. And coming to this 270, we can write it as 3 into 90. Here 3 is also odd number. So that's why we can call these angles as odd multiples of 90. And coming to this, here 0 is there. So 0 is an even number. Next 180. 180 means we can write it as 2 into 90. Here 2 is even number. So that's why these type of angles are called even multiples of 90 degrees. So why I am saying about this concept means, when we have odd multiples of 90 degrees, then the ratios will be changed. For example, if I have these type of angles, then the ratios will be changed like this. If sine is there, and then sine will be converted into cos. If cos is there, it will be changed as sine. Next, tan is there, it will be changed as cot, and cot is changed as tan. Next, cosecant, it is changed as secant, and secant is changed as cosecant. Now coming to even multiples of 90 degrees, ratios will not be changed. So ratios will remain as it is. Okay, for even angles, no change. Okay, these are the finally 3 steps. Okay, so once again I am repeating, the concept of all silver teacup says that here we have total 4 quadrants. Okay, so for first quadrant, all the trigonometric ratios or trigonometric functions are positive. Second quadrant, sine and cosecant are positive. Third quadrant, tan and cot are positive. Fourth quadrant, cos and secant are positive. This is the first point. Next, second one is the angles in the quadrants are, in first quadrant the angles are 90 minus theta, 360 plus theta, n into 360 plus theta and theta. Okay, so this theta is not needed. We have to remember these three. Next, in second quadrant 90 plus theta, 180 minus theta. In third quadrant 180 plus theta, 270 minus theta. In fourth quadrant 270 plus theta, 360 minus theta, n into 360 minus theta and minus theta. Okay, this is second point. Next, the third one is for odd multiples of 90 degrees, ratios will be changed like this. Okay, for even multiples of 90 degrees, ratios will remain as it is. Okay, this is the concept of all silver teacups. So if this graph, okay, if we have remembered this graph, with the help of this graph we can find the values of any degree with trigonometric function. For example, now I will apply this method in calculating sine 120 degrees. Okay, my question is to find the value of sine 120. Okay, so now observe here sine 120. 120 can be written as, with the help of these angles only we have to write the 120 degrees. Okay, so if you observe 120, I can write 90 plus 30 or 180 minus 60. Okay, don't write 120 as 100 plus 20 degrees or 80 plus 40 degrees like this, because we have the formulas for these angles only. Okay, so these are called allied angles. Allied angles nothing but, so the difference or the sum of the angles is 90 degrees or multiples of 90, because in quadrants, so if you coming to first quadrant to second, the angle will be more than 90 like this. So that's why we have to write 120 in the form of these angles only. Okay, now I am writing 120 as 90 plus 30. Okay, I can write 90 plus 30. Now first observe the angle. Okay, here this angle is in the form of 90 plus theta. Okay, 90 plus theta. So now think 90 plus theta lies in which quadrant? Okay, 90 plus theta lies in second quadrant. Okay, observation is over. The angle is in second quadrant. Next, observe the ratio. In second quadrant, sine positive or negative? Okay, it is positive. Okay, no problem. It is positive. Okay, now observe this angle. Here it is odd multiple of 90. So for odd multiples of 90, ratio will be changed. So it means sine will be changed as cos. Now theta means 30. So what is the value of cos 30? Cos 30 is root 3 by 2. Okay, finally the value of sine 120 is root 3 by 2. Now you can ask one more question, sir. You can write 120 as 180 minus 60 also. We can apply that also. Okay, for example, I am taking one more method. Sine 120 equals to, I can write it as sine 180 minus 60. Okay. Now observe. The first step is observe the angle. Here 180 minus theta. 180 minus theta lies in second quadrant. Okay, second quadrant. In second quadrant, sine positive or negative? Positive. Okay, no problem. And this is even multiple of 90. 180 means even multiple of 90. For even multiples of 90, ratio will not be changed. That means sine will be as it is. Now sine theta, in place of theta, 60 degrees. And we know sine 60. Sine 60 is root 3 by 2. Okay, in calculating the problems of these type, no need to consider both. You can take any one, but mainly we have to write the angle in the form of these angles only. These are called allied angles. So we have to write in the form of allied angles only. Okay, so we'll see the remaining problems in the next session. Okay, thank you everyone.